dealing with arc length here, but instead of radians, we're messing with degrees. All right. So anyway, this is the formula for finding arc length with the radians. Here's your nasty formula for finding the arc length if you know your angle in degrees, if you know the central angle in degrees. So they're the same formula. It's just this, that 2 pi and this 360 are kind of, they're offsetting each other. All right. So if you ignore the 2 pi and the 360, you're left with that r theta again. All right. So same formula as what we had up there. So that's all that's happening there. My personal opinion, I would prefer to just, if they give you degrees, I would just convert it all to radians and then use this formula. But that's me. I'll show you using this formula though. So find this arc length here. And it's not SA, it's just S. Sorry, I was thinking of something in the future. Just S. Find the arc length if you know that the radius is 4 and the central angle is 30 degrees. All right, so let's see here. The S is what we're solving for. That's the arc length. Get this out of your way. All right, so we've got 2 pi. The R is going to be 4. And let's see here. It's our theta over 360. And our angle theta is 30 degrees. So all we have to do really is simplify this side. Okay. Let's see here. 2 times 4, that's 8. See here, 30 over 360, I can divide by 10, and then 3 over 36, that is 1 over 12. So now I've got S equals, it's 8 over 12, if you multiply across, 8 over 12, that's the same as 2/3. So we would have 2/3 pi, or 2 pi over 3. That would be the length of our arc length out there. All right. If we wanted to do that like in feet or whatever, to make a decimal out of it, we would just do 2 pi over 3. So this would be like 2.09 feet, depending on how they want our answer here. All right, so 2.09. Oh, and yeah, if you wanted to, you could have just typed in that straight away from the very beginning. I'll show you here what I mean. So if you would have just taken 2, kind of ignore the pi for now, times the 4. Oh, that's not what I wanted. 2 times 4 times, and then this 30 over 60 part. You should have done that. 360. Would have got the same thing, 2/3. All right. Just don't forget to put the pi on there. All right. This one. So we've got, we know the arc length is 8.5. I want to emphasize here it's not pi. All right. They're not giving us them in terms of pi. The central angle is 135, and we are solving for the radius. Let me copy down that formula again. It was S equals 2 pi r, and then theta over 360. All right, so we'll just substitute in what we know. So the S, that's our arc length, so it's 8.5. Let's see here, that's equal to 2 pi r, and then theta over 360 is 135 over 360. There's a couple of ways we could do this. Let's see. What I'm going to do is I'm going to take that 2 and I'm going to multiply that on that 135. And I'm just going to simplify this whole fraction part, but including that 2. So I've got 2 times 135 over 360. Okay, so on the right-hand side, this is equal to 3/4. Okay, so I've got 8.5 is equal to I'll just do 3/4, and then we've got a pi r. All right, or actually, I'll tell you what, I'm going to put that pi up in the numerator as well. So we got 3 pi over 4 times r. All right, from here, we'll multiply by the reciprocal of this. So we'll multiply both sides by 4 over 3 pi. That way the 3 pi's can cancel and the 4's can cancel. We'll have to do that over here as well. 4 over 3 pi. All right, on the right side, like I said, those cancel. You're just left with r. On this side, we'll have 4 times 8.5 over 3 pi. So 4 times 8.5 is 34. So you wind up with 34 over 3 pi. All right, and then 34 over 3 pi will not simplify. If you wanted to find out what that radius was as a decimal, just divide that out. All right, 34 over 3 pi. See, about 3.6. That's what our radius was. About 3.6. Close enough. All right, and that's about it for that.